Hello everybody, we are just about at the end of another week. I hope you are doing well. This week's Think Outside the Box Thursday is going to have a little bit of something special for you. And that is, I'm giving away a prize. This is a bowl buddy. He hangs on the edge of your cereal bowl like so, and it is a little SpongeBob. And the first place winner for this week's Think Outside the Box Thursday, I'm going to put this in the mail for you on Monday. And that will be your prize if you win it. I hope you enjoyed today's lesson, and take care. Hey, hidden talent number 2 time. What we're talking about this week is kinetic energy, potential energy, work, and power. All these things are sort of interrelated. And as you see, when you juggle a ball, when it leaves my hand, it has a certain amount of energy. And when it reaches the top of the path that it goes up, it also has a certain amount of energy. What we're going to do today is a little mini lab where we look at kinetic energy, potential energy of an object when it's in motion, in the air like that. And I'm not going to use these balls because they're a little bit too small for that. But I'm going to use this football. And basically what I've got set up here is the motion detector, the LabQuest Mini, computer just like we normally use in class. And I'm going to start data collection. I'm going to try and get a nice smooth curve. I'm going to throw the ball straight up like this and try and get us a nice smooth curve. And then we'll look at the analysis of the kinetic energy and the potential energy of the ball while it's in flight. So here we go. I'm going to hit collect. Get ready here. And go. Hey, we got a smooth curve on the first shot. So we will take a little look-see at that and discuss it here. Okay, we're going to take a look at the analysis for the energy of a tossed ball lab. This is the basic setup that we had. Obviously, I've got the motion sensor right down here, and I tossed the ball up in the air. Obviously, it was not a round ball, it was a football, so we'll turn that into a football there. That's just lovely. Just love that. For all the calculations, we do need to know the mass, and the mass of the football was 0.4 kilograms. We'll use that for all of our formulas. For this particular lab, the only formulas that we need, this is technically not a work or a power lab, but an energy lab. The formulas that we're going to need are going to be potential energy is mgh, that is mass times acceleration due to gravity, which is 9.8 meters per second squared, times height off the ground or above the sensor in this case, and that's going to be in meters. Kinetic energy is 1/2 mv squared, that's 1/2 the mass times the velocity squared. Note the velocity is squared, that's going to be important in just a few seconds. And then the total energy is the potential energy plus the kinetic energy. What we're trying to see here is if the total energy in a system is consistent throughout the motion of the ball in the air. Here is the output for the velocity time graph on top and the position time graph on bottom. These should both look very, very familiar to you. They're just the exact same thing we did with the very first cart on a ramp lab that we did. Basically, this point right in here is when I'm moving the ball in an upward direction about right here is where it leaves my hand. So that's going to be right about here. Right here is the top of the curve. It's going to be right here. And right about here is where I'm catching it. Again, which is going to be right about there. So we have a positive velocity here as it's going up, negative velocity here as it's going down, and then this is just kind of some dead space here where I've caught the ball and it's wiggling around in my hand just a little bit. So for this particular lab, I used right at the point of toss, halfway up, top of the curve, halfway down, and the bottom of the curve right about the time that I caught it. So I had 5 data points that I collected, and at each of the data points I took the velocity from this graph, I took the time just so we can make sure we have the same time on the top graph and the bottom graph, and then I took the height off of this graph and then plugged them into the formulas. So I ended up with this data table right here. Again, the mass of the ball is 0.4 kilograms. Again, I took the time, the height, the velocity. Using the height and the potential energy formula, I came up with the potential energy. Using the velocity and the kinetic energy formula, I came up with the kinetic energy. And then I simply added these two together to give me the total energy of the system. So at the first point when the ball was released, which is this point right here, that's point number 1, point 2, point 3, point 4, and point 5. At this point right here, the total energy of the system measured out to be 3.95 joules. 3.95 joules. As you can see, when I added all 5 points, this point 1, 2, 3, 4, and 5, when I added all the points in and I calculated the total energy at each of the points, the potential energy went up and then it went back down. The kinetic energy went down, ended up being 0 at the top of the curve, of course, and then it went back up. And you'll notice the total energy of the system remained relatively consistent. I hope you enjoyed this first virtual lab. We'll be taking a look next week at catapults on aircraft carriers, which I hope you find very interesting. Thank you.